Hi students, welcome to my Dreamz Academy. Yeah, today we'll discuss azeotropes. What is azeotropes? Azeotropes are a binary mixtures of two liquids in fixed proportions which behave like a single liquid, and this boils at a fixed temperature. Those are isotropes. Liquid A, liquid B. They are behave like a single liquid. These solutions are called as azeotropes. These azeotropic mixtures cannot be separated either by distillation method. They are only separated by azeotropic distillation. But ideal solution cannot form azeotropes. So students, what is azeotropes? A binary mixture of two solutions, mean two liquids. Like these two liquids, one is in liquid phase, other one is in vapor phase. I can mix this both liquid phase and vapor phase, fixed proportion, which behave like a single liquid, and these are boiled at a fixed temperature. Those solutions are called as azeotropes. These azeotropes can classified into two types. I discussed already our previous classes ideal and non-ideal solutions. A non-ideal solution can classified into positive deviation and negative deviation. Same here, azeotropes can classified into two types: minimum boiling azeotropes, maximum boiling point azeotropes. Then what are minimum boiling point azeotropes? Non-ideal solution showing positive deviation can show minimum boiling point azeotropes. Non-ideal solution showing negative deviation can show maximum boiling point azeotropes. నేను ఆల్రెడీ డిస్కస్ చేసా ఐడియల్ నాన్ ఐడియల్ ఎగ్జాంపుల్ ఎలా షార్ట్ కట్ లో మనం దాన్ని గుర్తుపెట్టుకోవాలో. మనం ఐడియల్ సొల్యూషన్స్ అయితే సేమ్ ప్రొనౌన్సియేషన్, నాన్ ఐడియల్ సొల్యూషన్స్ అయితే పాజిటివ్ అండ్ నెగిటివ్ ఉంటుంది. పాజిటివ్ డీవియేషన్ లో మోస్ట్లీ ఆల్కహాల్స్, నెగిటివ్ డీవియేషన్ లో మోస్ట్లీ యాసిడ్స్. ఇంకొక సెకండ్ ట్రిక్ చెప్పాను నేను మీకు లాస్ట్ ప్రీవియస్ క్లాస్ లో. పాజిటివ్ డీవియేషన్స్ లో మాక్సిమం కార్బన్ టెట్రాక్లోరైడ్ విత్ ఏ కాంపోనెంట్ ఉంటే అది పాజిటివ్ డీవియేషన్, క్లోరోఫామ్ తోటి ఉన్నటువంటి ఏ మిక్చర్ ఉన్నా అది నెగటివ్ డీవియేషన్. సేమ్ లైక్ పాజిటివ్ డీవియేషన్ ఎగ్జాంపుల్స్ సేమ్ మినిమం బాయిలింగ్ పాయింట్ azeotropes, నెగటివ్ డీవియేషన్ ఎగ్జాంపుల్స్ as maximum boiling point azeotropes. Then we'll move. Our next topic is colligative properties. One of the most important topic in your solution chapter. ఇది చాలా important chapter, colligative properties. మీరు ప్రీవియస్ క్వశ్చన్స్ చూస్తే జేఈ మెయిన్స్ వాళ్ళైనా నీట్ వాళ్ళైనా నెంబర్ ఆఫ్ క్వశ్చన్స్ కాలిగేటివ్ ప్రాపర్టీ బేస్ ఉన్నాయి. చూద్దాం మనం. వాట్ ఈస్ కాలిగేటివ్ ప్రాపర్టీస్? Properties of solution which depend upon number of particles of solute. Number of particles of solute and not on nature of solute. దేని మీద డిపెండ్ అవుతుంది colligative property? Number of solute particles but not nature of solute particles. For example, మనం ఇప్పుడు బస్సులో ట్రావెల్ చేస్తూ ఉంటాం. బస్సులో ట్రావెల్ చేస్తున్నప్పుడు కండక్టర్ టికెట్స్ ఇవ్వాలి అంటే వాళ్ళ నేచర్ మీద డిపెండ్ అయ్యి టికెట్ ఇస్తాడా, నెంబర్స్ మీద డిపెండ్ అయ్యి టికెట్ ఇస్తాడా? నెంబర్ మీద డిపెండ్ అయ్యి టికెట్స్ ఇవ్వడం ఉంటుంది. అంతేగాని లావున్న వాళ్ళకు ఒక టికెట్, సన్నగున్న వాళ్ళకు ఒక టికెట్ అలా ఉండదమ్మా. సేమ్ యాజ్ కాలిగేటివ్ ప్రాపర్టీస్ ఆల్సో కెన్ డిపెండ్స్ అపాన్ నెంబర్ ఆఫ్ పార్టికల్స్ ఆఫ్ సొల్యూట్ అండ్ నాట్ ఆన్ నేచర్ ఆఫ్ సొల్యూట్. కాలిగేటివ్ ప్రాపర్టీస్ గివ్స్ బెస్ట్ రిజల్ట్. ఇది ఎప్పుడు బెస్ట్ రిజల్ట్స్ ఇస్తుంది కాలిగేటివ్ ప్రాపర్టీ? సొల్యూట్ డస్ నాట్ రియాక్టెడ్ విత్ సాల్వెంట్ and solute is a non-volatile in nature and solution is a dilute and solute is should neither dissociate nor association. ఈ కేసులో కాలిగేటివ్ ప్రాపర్టీ బెస్ట్ రిజల్ట్స్ ఇస్తుంది. ఇంకొక ఇంపార్టెంట్ పాయింట్, కాలిగేటివ్ ప్రాపర్టీస్ is directly proportional to concentration of solution. Colligative properties is directly proportional to moles of solute but inversely proportional to quantity of solution or solvent. చెప్పండి, what is colligative properties? Properties of solution which depends upon number of particles of solute and not on nature of solute. The best results. solute does not react with the solvent, solute non-volatile undali, solution is a dilute, solute should neither dissociation nor association, and the colligative properties can directly proportional to concentration of solution. Colligative properties is directly proportional to moles of solute, inversely proportional to quantity of solution or solvent. Before colligative properties, we'll discuss want-off factor. What is want-off factor? Want-off factor is a ratio in between normal molar mass divided by abnormal molar mass. Or another definition, want-off factor, observed colligative properties divided by theoretical colligative properties. From this formula, I can calculate observed colligative properties. Observed colligative properties, that is equal to want-off factor can multiply with theoretical colligative properties. And one more definition, want-off factor is the ratio of number of particles, the ratio of number of particles formed after dissociation or association divided by before dissociation or association. We'll discuss calculation of want-off factor. What is association? What is dissociation? Solutes can classify electrolytes and non-electrolytes. What is electrolyte? What is non-electrolyte? Which gives ions in water. Electrolytes does not give any ions in water. Those are non-electrolytes. What are non-electrolytes? Example is urea. Molecular formula is NH2CO NH2. Glucose C6H12O6, sucrose C12H22O11. This is our urea. Glucose, sucrose. These substances are non-electrolyte. Mostly organic compounds are non-electrolyte. Doesn't give any ions. In this case, their alpha value is always alpha and want-off factor. Want-off factor I is 1 and alpha is equal to 0. This is for non-electrolyte case. Then what is electrolyte? Yeah, electrolytes are which gives ions. What is electrolyte? Which gives ions. These electrolytes can classified into two types: strong electrolyte, weak electrolyte. What are strong electrolyte? In case of acid, strong acid, base, strong base, and all types of salt. Then what are weak acids? Weak electrolytes, weak acid, weak base, all types of salts. These are strong electrolyte, and this is weak electrolyte, and this is non-electrolyte. In non-electrolyte, want-off factor I is equal to 1. Degree of dissociation alpha is equal to 0. Reason doesn't give any ions. Mostly organic compounds are non-electrolytes. And these are electrolytes. What are strong acids? Hydrochloric acid, nitric acid, sulfuric acid, perchloric acid. What are base? Sodium hydroxide, potassium hydroxide, salts like NaCl, KCl, Na2SO4. I discuss here few examples only. And these are the weak acids: hydrogen fluoride, hydrogen cyanide, and acetic acid. And weak base is ammonium hydroxide. So we'll discuss calculation of want-off factor. How to calculate want-off factor? In calculation of want-off factor, there are three cases. One is a dissociation, association. One more is previously discussed, non-electrolyte. So this is dissociation case. What's it? Dissociation case, AB is a electrolyte, and this AB can dissociate, then get here A plus and B minus. Then how to calculate want-off factor I? I is equal to 1 plus n minus 1 into alpha. There, where what is n? N is equal to number of particles formed after dissociation of one compound. This is our one compound. After the dissociation, of one compound, that is n. From here, what is alpha? Alpha is equal to degree of dissociation. Alpha is equal to degree of dissociation can calculate from this formula, Quanta factor I minus 1 by n minus 1. If our dissociation case, Quanta factor I value is always greater than 1, mean theoretical colligative probability is greater than absorbed. Mass of theoretical is greater than absorbed. In what is association case? Yes, this is association. It is not a dissociation case. If it is a atom A, atom B, two atoms can associate, then form A2. How to calculate Quanta factor for association case? I is equal to 1 plus 1 by n minus 1 into beta. Where what is beta? Beta is degree of association. How to calculate beta? Quanta factor minus 1 divided by 1 by n minus 1. Where what is n? N is equal to different for the dissociation case and association case. Whether it is dissociation, our n value is equal to number of particles formed after dissociation of one compound. And the association is, yes, number of particles that combines, to form one compound, that is our en. For the association case, Quanta factor I is always less than 1, mean theoretical is less than observed. I'll discuss some questions based on your Quanta factor. I'll give one more best trick. This is the calculation of Quanta factor I, method number 2. If it is 100%, percentage dissociation, percentage association, percentage into n, percentage into 1 by n. Method 2. Method 1 is I is equal to 1 plus n minus 1 into alpha. For association case, I is equal to 1 plus 1 by n minus 1 into beta. Method 2. If it is 100% mean, percentage dissociation, percentage association, percentage into n, percentage into 1 by n. Calculate. I'll discuss one question. AlCl3 dissociation 60%. Calculate Quanta factor. Quanta factor, method number 1. AlCl3 dissociation. First to dissociate AlCl3, this is one compound, can dissociate. After dissociate, I'll get Al plus 3 times of Cl minus, where n value is equal to 4. Substitute Quanta factor I is equal to 1 plus n minus 1 into alpha. I is equal to 1 plus n value is 4 minus 1. Alpha is 60%, means 60 by 100. So I is equal to 1 plus 3 into 60%. 0 cancel here, 0 means this is 0.6. So I is equal to 1 plus 3 into 0.6, that is 0.18. 6 3s are 18. 0.6 into 3, 6 3s are 18. 1.8 plus 1, 2.8. That is I is equal to 2.8. Is it greater than or less than? It is greater than. So in this dissociation case, I greater than 1. Can solve the method 2, percentage into n. Percentage into n. Percentage into n. How much percentage dissociate? 60%. 60 into what is n value? N value is equal to 4 plus complete 100. In 100, 60 is dissociate. 40% is left. Should can add 40 by 100. That's the second method. Percentage 60 into n. N value is 4. 60% mean total 100, 60 is dissociate. How much percentage is left? That is 40. Should be add 40. Acetic acid is 40% dissociation. Then find the Quanta factor I is equal to acetic acid. How to dissociate acetic acid? CH3COOH. Can dissociate, you will get CH3COO minus H plus. Where n value, n is equal to 2. Then Vanta factor I is equal to 1 plus n minus 1 into alpha. So I is equal to 1 plus n is 2 minus 1, 40% mean 0.4. So I is equal to 1 plus 1 into 0.4. 0.4 plus 1, 1 point. So I is 1 point. Is it greater than or less than? Greater than. This is your Vanta factor calculation, association and dissociation. థ్యాంక్ యూ. ఇంకా షార్ట్ కట్స్ కోసం మా యూట్యూబ్ ఛానల్ని సబ్స్క్రైబ్స్ లైక్ చేస్తూ ఉండండి. మీకు కావాల్సిన కంటెంట్ ప్రొవైడ్ చేస్తూ ఉంటాం. థ్యాంక్ యూ.